Hi class, this is Mr. Morris. We could have you go ahead and find the molar masses of these again, and it might not be a bad idea for you to just double check and make sure that you get the same answers, especially for this one. This one's a little bit tricky. But often on a problem like this, you're going to be given the molar mass. So that's kind of what we're doing here, and it also saves a little bit of time. So a chemist mixes, this is our question, a chemist mixes 5.78 grams of aluminum. It says aluminum foil, but that's still aluminum, in a solution containing 0.485 moles of HNO3 in a beaker. Okay, so we've got our two reactants. Now this is what I want you to make sure you can recognize. If I give you the amounts of two reactants, you know we're going to have to figure out which one is the limiting reactant. Okay, so both of those are on the reactant side. We got to figure out which one's the limiting reactant. Now let's read the question carefully, including units. It's very important to read carefully. It says determine the moles of both reactants. Well, one of these already has moles. That's the HNO3. So one of them we're already done before we even begin, really. 0.485 moles of HNO3. That's half of the answer for part A. Now the other half we've got to figure out. It says whether asked or not, remember, whether asked or not, we need to know moles of the substance before we work the problem, because the chemical equation is written in terms of moles. So recalling that, we need to find moles of aluminum. We've got our mass of aluminum up here. We're going to use that. So 5.78, that's the molar mass of aluminum. We have 5.78 grams is our mass that's given in the problem. 5.78 grams of aluminum. And then we're going to use the molar mass of aluminum, which is, again, 26.982. grams of aluminum in 1 mole of aluminum. Crunch the numbers, and you should get 0.214 moles of aluminum. So I have 0.214 moles of aluminum, and I have 0.485 moles of HNO3. Part B says determine the limiting reactant. So we're going to determine the limiting reactant in this reaction, justify with calculations. Remember, we do this by making two fractions, one for each reactant, and compare them. Okay, so I've got aluminum is 0.214, and we've got to find our coefficient for aluminum. It's 2. Okay, 0.214 over 2. That's 0.107. Remember, that answer doesn't have units because our moles actually canceled out. Or if you wanted, you could put moles of reaction. All right, and then the other value we're going to use is moles of HNO3, 0.485 moles of HNO3. And then in the denominator, we need to look at our equation, 6 moles of HNO3. So those are two different fractions. 0.485 over 6 will give us 0.0808. Again, no units. All right, so our question here is which one's the limiting reactant. Remember, the reactants are aluminum or HNO3, and again, these cancel out, these don't have units, but what we want to do is find which one gives us the fewest batches, the fewest moles of reaction. So the smaller number here is definitely that one. So that tells me HNO3 is the limiting reactant. That's very important that you answer the question. That's what the answer would be. That's our limiting reactant. So the question is, what substances would be present in the beaker after this is complete? well, the limiting reactant will be gone, so we'll have the excess reactant left. Excess reactant is aluminum, so we'll have aluminum because it's the excess. And we're going to have products. Remember, what's left in the beaker after the reaction is completed is excess reactants and products. So what are the products of this reaction? AlNO3 and H2. So aluminum nitrate and hydrogen are also in there. So we've got our excess reactant or reactants and our product or products. Okay, now we want to determine the moles of excess. Determine the moles of excess reactant consumed. Okay. So the moles of the excess consumed, that means I'm looking for aluminum. Okay. Going back to our problem, aluminum is X now. And I'm going to always use my moles of limiting reactant. So 0.485 moles of my limiting reactant divided by 6 moles of HNO3. So 0.485 moles of HNO3. Once we find the limiting reactant, that's our given from now on, over 6 moles of HNO3 equals, I want to know how much is consumed in the reaction, how much of our excess reactant, which would be aluminum. So X moles of aluminum over, looking at our equation, 2 moles of aluminum is what the equation says. So we could rearrange and say 6X equals 2 times 0.485 or we could even take that over here and say X equals 2 times 0.485 divided by 6. And putting that in your calculator, you ought to get something like 0.16, and then it's 1/6, so that rounds up to 2. And that's moles of our excess reactant that was consumed, moles of aluminum consumed, or in other words, used. Okay, so that's what I used. This says we want to find the mass of the excess reactant remaining. Now there's a couple ways you can do this, but I know the moles of aluminum that were available. If we look back at our problem up at the top, the moles of aluminum available was 0.214. I know moles available. So I'm going to start with that. Available minus used. And that's going to tell me what's left over. Okay, so I'm actually going to find first moles of leftover aluminum. It's just the way that I think is the easiest to do this. 0.214 minus 0.162. When I do that, I get 0.052. 0.052 moles of aluminum that remain. Pay attention though, I asked for the mass. I'm asked for the mass that remains. So I do have one more step. Now that I have the moles that remain, I need to convert it to grams. So I'm going to put 0.052 moles of aluminum, and I'm going to multiply that by the molar mass of aluminum, which we have up here at the top, 26.982. over 1 mole of aluminum. So we're canceling out our units. Remember to always check and see if you have the units you're looking for. That kind of goes back to the steps on the first page. First page of these notes says we're going to find the number of moles of the given, solve for the moles that you're asked for, and then convert your answer to the units that are asked for. So always check to see if you have the units that you've been asked for. In this case, I still needed to convert to grams, and that's what we're doing right here. And I get 1.4. 1.4 grams of aluminum left over. All right, calculate the moles of hydrogen gas that would be produced. So I've got moles of hydrogen gas. That won't be too hard. I'm just going to use my limiting reactant again, 0.485 moles of HNO3. Over, from our equation, we know that's 6 moles of HNO3 equals X moles of H2 gas over, well, how many moles of H2 do we have in our equation? Looks like there are 3 of them. Rearrange to solve for X. End up with 6X equals 3 times 0.485. Divide both sides by 6. So we end up with X equals 0.243 moles of H2. Double check to make sure those are the units we're looking for. And they are. And then finally, one last step. Calculate the mass of AlNO3 that will be produced. Try this one on your own if you feel comfortable with it. Always start with your limiting reactant. So it's going to be the same setup as the last one, 0.485 moles of HNO3 over 6 moles of HNO3, since it's still the same reaction, equals, but this time X is going to be moles of AlNO3. I've got to start with moles, and then I'll convert to mass afterward. Now let's find AlNO3 in our equation. Coefficient is 2. Those are 3s, sorry about that. Okay, cross multiply. We end up with 6x equals 2 times 0.485. Divide both sides by 6. Then you're going to end up with x equals 0.162 moles of AlNO3. Well, that's fine, but that's not really what I'm looking for. I'm looking for the mass. So one more step in our problem. We need to multiply by the molar mass to convert to grams. So again, at the top of the page, our mass of AlNO3 is 212.994. So when I go to calculate that, I get 34.5 grams of AlNO3. That is what the question had actually asked for, I believe. Grams or mass of AlNO3. Go ahead and try your hand at the practice and let us know if you have any questions.